This video is going to be walking you through the activity for the week. It's your cell analogy assignment. Now in this assignment, which we'll pull up in a second here, you're going to need to be making a model, a real life model, that simulates the cell. And you're going to have some options to pick. You can either compare a cell to the school, to a book, to a mall, an amusement park, a computer, an airport, or you can make your own. You must include at least 12 organelles in it, and you must explain your choice, and you also have to create a drawing on the model. Okay, so here's the sheet that you need to fill in, saying the part of the cell and the function and the comparison, and then at the end I'm going to show you an example of what the picture looks like. So you'll just need to fill out this table and create an analogy. So this is what the analogy could look like. For this lesson, we're going to be comparing it to a city. So let's take a look. So the part of a city that the cell membrane can represent would be city limits. So it's where the city starts and ends. So if you remember what a cell membrane does, it allows things in and out of a city. So how do you get into a city? Well, you cross over the border and now you're in the city. So there you go. Cytoplasm. In a cell, it's that empty space that holds everything. So we could call it public lands. So let's call them like city parks maybe, because it's what fills in all the spaces. I mean, if you don't have houses or a mall or something, what do you have? Well, you have a city park, right? Mitochondria, where do we get all our power from? Well, I don't know, power plant, right? We've got to make power somewhere, so we make it in a power plant. The ribosomes, they're the workers, right? So we're going to represent that by factories, and it's where we make stuff, so we'll just call them factories. Endoplasmic reticulum, well, they supply parts to the ribosomes, right? So let's say you're working in a factory, where would you go to get it? Well, in our example, we're going to call it Home Depot, right? Because you go to Home Depot to buy parts for building things. Vesicles, they're used for transporting stuff around the cell. So here we're going to say transportation trucks, they like to move stuff around. Okay, so, just a big 14-wheeler or whatever. Next example would be the Golgi body. The Golgi body packages stuff up, so we'll call it a moving company. So they package people and homes up, or delivery trucks, like UPS or Amazon or whatever, those kind of things. So those would be an example of a Golgi body. They move stuff around the city. The nucleus, the control center. Well, who's in charge of the city? Well, it's City Hall. It's our councilors and our mayor. So that would be the nucleus, the City Hall. Vacuoles is where we store stuff. Now, in the explanation I gave you earlier, it was for food, but it also stores waste. So I'm going to go with the waste example here. So it'll be the warehouse or a dump. It's where things are stored. You can also use we could put in a grocery store, for example, because that's where food is stored. Cytoskeleton, so that's kind of the infrastructure that allows things to move around in a city. So here we'll have city roads. So as you'll see in my example, I drew some city roads. That's how we get around, right? Connects all the parts. The cell wall. Now the cell wall provides structure and support. So city walls and gates, it protects the city. Now I think in my drawing, instead of drawing a city wall and gates, we don't have walls or gates in Brampton. What I ended up drawing was the police, because they protect and support the city, right? Could be the fire department, police, could be, right now it's probably our doctors and nurses, right? Like that's pretty important, so that. And the last one is the chloroplast. The chloroplast is where we do all the photosynthesis and make sunlight out of energy, and I thought solar panels would be a very, very easy example. So what I'm going to show you now is my actual drawing. So I just did this on my desk, took about, 10 minutes or so, and I'll show you all the functions. So this is welcome to Brampton. It's the city of Brampton. So what I have here is I have the 4 roads that kind of on the outside of Brampton that make its borders. So like Winston Churchill, Mayfield Road, I think it's Gore Road, although I'm not sure. And then I know it's Highway 7, or not Highway 7, the 407, Highway 407. Okay, and that's the boundaries of Brampton. Well, that's also the cell membrane, isn't it? It's just the boundaries, right? What else do I have? Well, here I got a little drawing of a power plant. I called it the mitochondria because that's what we get our electricity from. Let's see, I have these big roads going through. So let's say Highway 10 and Bramalea and Queen and Sandalwood. Well, those would be our cytoskeletons. So I gotta label those, right? Those are cytoskeletons. Let's see, what do we have up here? I have a house, but I drew the house because I just wanted to put some solar panels on it, and that'd be like our chloroplast, right? We're making solar energy, and then we have a U-Haul truck, which is the Golgi, right? It's packaging, moving stuff. I have a few kind of public parks, so I have Heart Lake and Gage Park and Professor Lake. Those are all public lands. Those would be their cytoplasm. There's City Hall. That's the nucleus. Home Depot is where we get our parts. It's the ER. There's the vesicle moving stuff away from the ER. It's a transport truck. Let's see, what else do I have here? Here's my landfill, where we just dump useless stuff. In fact, I actually put it near my house. I live down here in the south end of Brampton. That's the landfill. In fact, there's quite a lot of landfill under our football field at school. Although it's not garbage, it's just like stuff they dug up for other houses and threw down there. Our school used to be a marsh and had a river going through the field in the back of our school. And then let's see, what else do we have here? Oh, we have the samosa factory, which I love. They great samosas, and we'll call it the ribosomes because that's a factory. They're making work. There's our little police car. It's our cell wall, and yeah, that's about it. I have all the organelles on here, and I drew a little map trying to justify my answers, and there we go. So if the city was a cell, this is what it would look like. So if you go back to the assignment quickly, then that's what you need to do. Right? Instead, you'll do it as a school or a book or a mall. Now, if you're having problems finding how to connect these to the cell, then you can ask me. Send me an email or say, hey, sir, can we talk on the phone or can we hop on Teams? I don't even mind if you know someone in the class, if you want to talk with them and share and do one together, that's fine. You just have to have your own drawing. I don't want to have any duplicate drawings, right? So this drawing has to be your own, but if you want to kind of crowdsource it and work with someone else in the class to try to, get this whole chart done out, that's great. So again, to find the function of the cell part, you definitely want to look at the video and the PowerPoint that I posted. You're going to put in what your model is here, and so when you say cell membrane, function is to let things in and out, and then for me it'd be the borders, right, and then explain why the comparison is proper. Okay, so you'll have to download this document. You'll have to probably click enable editing, and then that document's yours. If not, you can make your own chart if you want in a Google Doc and submit that. At the end of the day, you just take a picture of your picture that you drew and insert it in. If you want to do it using some sort of digital program, feel free to do it. And yeah, that's what you have to do for the week. But again, if you need help, let me know. Happy to help you. Okay, take care. Bye.